right, welcome for joining this session, which I called Welcome to the AI Jungle, Now What? And so we all have heard about AI, especially here at Devox as well. There's a lot going on. And maybe you want to do AI too, or maybe your business leader is asking you to do something with AI. But what now, right? Let's go to the landscape and holy moly, right? There's this is the landscape as of March of this year of kind of the AI landscape, and there's a lot of projects, right? So if you're familiar with the CNCF landscape, if you've ever seen that, that's also kind of overwhelming, and we're seeing a little bit of the same. This is of course inspired by that. I didn't make it. The accreditation is here at the bottom, but I found it pretty interesting. And this was in March. We're now in October, so I'm guessing there's even more projects. So how do we get started with AI, right? Where do we go, and what is the right path to using AI? So we've kind of been here before. So if you think about it, we were in this world of operating systems a long time ago where we had proprietary systems, quite expensive, especially for serving applications in production and application servers too, right? And then we kind of moved to Linux and to smaller application platforms and maybe even containers, right? So we moved also to cloud computing, and that kind of opened the world as well to a lot more use cases, way easier scaling, easier deployment. Maybe debatable, but there's been a lot of innovation in cloud computing, and thanks to these new kind of operating systems and everything. And now we're kind of in this new world of AI and machine learning and all that. And kind of the common theme between all of this is this, right? It's open source. This is what really has fueled innovation with the operating systems moving, to Linux, with application servers moving to just, very small runtimes that we can deploy, that we don't have to pay, tons of money for to serve our applications. And we've seen that in the cloud computing world, right? Moving to Kubernetes, yes, there's still, of course, a price to pay, but, thanks to open source, we've kind of made sure that all these big vendors had to work together to solve problems, and that has innovated a lot more, right? So all these kind of projects in that cloud computing landscape, a lot of them are open source, and a lot of these vendors are, kind of making sure that what they're offering is also open source because that's what we are demanding from them, right? And so we need to make sure that we're doing this with AI as well. We have learned kind of our lessons from the past, right? If we use open source, they're forced to use open standards, and we can collaborate together, and that's going to really, improve the open source. Wow, this little fly is flying in my face, and that's going to, help us all in terms of innovation, but also in terms of security, right? If you think about open source, we've seen that if everybody has their eyes on it, we can catch issues a lot faster and fix them because we're working together, right? So open source really, I think, is key to AI these days. Now let's take a step back, and kind of go through this path of adoption of AI, and in particular generative AI, because that's kind of what we're doing today, right? That's what a lot of the hype is about. And so the typical path, if you want to get started, is probably something like this, right? You start with some sort of ideation, prototyping, where you maybe find an LLM. You might start with ChatGPT or something. You might go to Hugging Face, find a model that works for you. You're going to try it out, prompt it, see what it gives back, because all these models are different, right? They come up with sometimes vastly different responses to your questions based on how they've been trained and how the weights are and everything. But anyway, so then you can experiment with your data. So that's the first step. And then once you've done that, you probably want to, refine it for your use cases, right? So that can be training the model itself, fine-tuning the model, but that can also be using techniques like RAG, which I'm assuming you've heard about at this conference as well, where you can augment the knowledge of the model with your own data without training the model itself. And then what's really kind of key too is we need to then operationalize this model, right? Because yeah, we can play around with models, we can get some stuff back, but how do we get this into production? And that's where we're seeing a lot of organizations kind of struggling, because yes, cloud providers are happy to provide a platform to host your model, but what's behind that is not really clear right now, right? It's not like with cloud computing, where we know, yes, you're probably using Kubernetes and you're using some projects on that CNCF landscape, and we can use those together. And if we want to move to a different provider, to some extent that's possible. In the AI world, it's still a little bit loose, right? So let's start with this ideation and prototyping. So, like I said, maybe you'll go to Hugging Face. So Hugging Face is this kind of repository for a lot of models. And a lot of these models are open source, and I put it in quotes because it's a little bit debatable, what exactly open source AI means these days. But you can go to Hugging Face and find a model that maybe for prompting and getting some text back. Maybe it's a model that returns some images or even videos, or there's lots of models out there. So I took this screenshot a while ago. 684,000 different models at that time. Now there's over 1 million. And there's a good reason why there's that many. It's not because everybody's creating models from scratch. The issue is with the open source concept of these models. Really, that's a little bit of a problem, right? Because I would say maybe, and this is a total guess, this is not scientific, but I would guess, about 80%, maybe even more of these models are all just derivatives of, some, a handful of models out there that have just been kind of slightly fine-tuned for somebody's use case. And they fine-tuned it to add some interesting knowledge, and that may be something very specific to their organization, but a lot of times, it could be interesting for everybody to use, but how do you contribute back, right? So I asked ChatGPT, I went to ChatGPT, and I asked, what is open source? And give it to me in one sentence. I don't want like a whole explanation of it. And it replied with, open source refers to software whose source code is made publicly available for anyone to view, modify, and distribute, right? So what's really key here, what I found really interesting is that OpenAI responds with this open source definition, which I think is pretty close to correct, but it says for anyone to view, modify, and distribute. And I might even say, modify, distribute, but also, contribute, right? Open source really works that way. It's not just using something, it's contributing back to it and making it better. So we can all work together on this. And that's where really the issue with AI right now is, I think, in terms of models, there's not really a good way to contribute back. And so we want to change that. So one project out there that's trying to help with that, so I'll highlight a few projects throughout this talk. This one is kind of trying to address this issue. So it's called InstructLab. And so this InstructLab model is trying to kind of democratize AI models, not only in terms of you can contribute back to models, but also in terms of how can you train and fine-tune models without being a data scientist and knowing Python and all these libraries. And so the idea with InstructLab is that you have this taxonomy-driven data curation where you basically have this folder structure of different areas of knowledge, and then you can add your own kind of data to it by creating a YAML file that has some specific data about your use case. It can be knowledge, it can also be skills. And so basically it's just a YAML file, and I'll show that in a little bit in a quick little demo. And then so you add that data, and then of course you need to fine-tune your model, and which is not so easy. I'm not a data scientist, so it's quite a daunting task to start training models. But here's the interesting thing with InstructLab is, you basically have a CLI, you give it some, a YAML file that points maybe to some maybe a file on my GitHub or my LinkedIn profile or, anything out there in the world, and it can start training on that. This training usually requires quite a bit of compute power, GPUs, and whatever more. InstructLab tries to also democratize this training part by doing this new technique, the large-scale synthetic data generation. It's a big word, but basically it allows you to train your model on your local machine, and it's going to generate kind of its own data based on what you gave it, so it kind of trains itself based on what you provided, but then also kind of augments it with its own data. Long story short, it makes it a lot easier to train. So I'm not going to go through the training today because I don't have any dedicated GPUs, and you can see it's a fairly small laptop. So to be honest, it did take several hours to train my model, but I just want to show you real quick what I did. So this is just a very simple file here that I put in my GitHub that just has some information about me. And so then I created this YAML file. So you can see here on the left, there's this taxonomy folder. And so it has compositional skills, foundational skills, and then it has knowledge. And then inside the knowledge, you have different folders, right? Arch, engineering, blah, blah, blah. In this case, I think I put it, I created a new folder, people, and then Kevin. And then I wanted it to add some information about me to see, like how does this work? So first, I'll start a model that does not have this information already. So you can do that with the InstructLab, or you can serve it differently as well, of course. So you can do iLab model serve, and then it's going to serve its default model, I believe. Let's see what happens. Yeah, so in this case, it's using a Merlinite, so this model that it uses by default, and it's now running on my local machine. And so now I can try to chat with it. So iLab model chat. And then I do this GM. Basically, that means that I want the temperature to be 0. I want it to be very kind of deterministic in its answer and not start making up a lot of things, even though it might still do that. But, let's ask it, who is Kevin Dubois? Just to, kind of see if what it's going to answer. I don't know what it's going to answer, of course, because that's the fun with AI models. You never know what's going to happen. Usually this goes a little bit. Okay, there we go. So I'm now a French professional ice hockey player. Wow, cool. I play in Rouen. Wow, that's awesome, but that's not me, right? So I'm gonna quit from this thing. So this was the untrained model. So then I trained it based on this YAML file. So you give it a bunch of question and answers, and then you can also point to some knowledge files, right? So I gave it some question and answers to kind of tell it how it should train itself. And so now let's try this trained model. So I'm going to close this one, stop this one, and then I'm going to go to model serve, and this is the trained model. So this is the ggml model f16, whatever more file that I created. So I'm going to start serving that. And once it is up and running, there we go. I'll go back and start another chat. So iLab model chat again. And this should now point to this trained model. And let's see what happens, right? So I guess I'll ask it the same question, who is Kevin Dubois? And then I hope that it's going to do something that is a little closer to reality. You never know, of course, because I gave it very little information. And because we need enough training data, it might still hallucinate a little bit, but we'll see what it says, right? So here we go. Kevin Dubois is a Belgian documentary filmmaker. No, but I am Belgian. Wow, okay. Yeah, so it's closer. I guess I need to change careers. Yeah, but that's cool. At least it's a little bit closer. I'm going to ask it maybe a different question. So where is Kevin Dubois from? And, well, it already said a Belgian documentary filmmaker, so it should still know that I'm Belgian. So let's see. Kevin Dubois is a Belgian professional road cyclist. That's classic. All right, so close enough. But anyway, if I had given it more information to train on, it would have been, of course, a little bit more accurate. But I gave it, just a little file here that was just in GitHub, right? So it was very little information. So maybe if I'd given it some more information. But anyway, so I hope this shows you that you too can start experimenting with these models as well. And play around with it. So the cool thing here is that you can contribute this back. So right now, this is supported not by every model that's out there, because a lot of these model providers claim to be open source, but you cannot contribute knowledge back, right? A lot of these models, or almost all models, you don't know the sources that it's trained on. And that's a problem for a lot of organizations. I know, for example, IBM is doing a pretty good job with open sourcing some of their models. So the Granite models, you can actually contribute back to them with InstructLab. So there's some traction at least. So that's one open source project that we can play around with if we want to get started with AI. Of course, there's a lot more, but that's one. So let's move on to kind of the building and refining, even though we kind of already did with our InstructLab project. If we want to work with AI in our organization, it's not just one person, right? It's not like one data scientist that's going to do everything. It's not going to build the model, serve the model, operationalize it, make sure it's stable, and then also consume it in applications, right? We have different personas that need to work together to, really get AI, give it some value at your organization. So, you have the business leadership who might set the goals, the data engineer that, gathers and prepares data. We have the data scientists, of course. They will develop the models, train the models, tune the models, and then, they also need to have some insights into monitoring and managing. The ML engineers, they set up a platform because, a data scientist can work on their laptop for a little bit, but it'd be nice if we can collaborate together as a team. And then, of course, let's say the more traditional application developer, they want to use these AI models into their systems, and that's how we can actually get value out of it. So everybody needs to work together, yes, even the operations team, right? Because we still need infrastructure underneath. So we need some platforms for AI. And so, kind of going back to what I was saying earlier about open source here too, it's important that we embrace open source, right? So again, there's many providers out there that provide some sort of an AI platform for you, but it's, again, what is behind it is not entirely sure all the time. So, it's good to know what's possible in terms of AI. So, because we have many deliverables that we need to think about, right? So in terms of storage, in terms of, maybe the data scientists want to use Jupyter notebooks and they need access to the data. They need to serve the model, but they're not going to be experts into, how do I serve applications and models? What about exposing the APIs and all that stuff? How do I take care of CI/CD? Because yes, that's also important. So there's all these kinds of considerations to make for an AI model. So if you look at, kind of the projects that are out there for the different, for the different deliverables, we see that there's a lot of projects and a lot of open source projects as well. For every layer, right? For machine learning libraries, the language and the development tools that we have, where do we store it? How do we serve it? So how do we bring that together in a meaningful way in our organization? And so a platform is not something you just kind of slap together, right? You need, some opinionated way, ideally, to get started. Mature projects to some extent, or maybe you want to experiment, but bring those all together. So you need stability and whatever more. So what we've learned from I would say the past is maybe not correct because we're still learning this, but in terms of software, we've learned that using a platform like Kubernetes is kind of key to be able to deliver applications these days, right? That doesn't mean maybe we still have legacy applications, but going forward, or at least the industry overall, has kind of converged on, Kubernetes is a good platform to serve applications and to scale them and to deploy and whatever more. So let's leverage this for AI as well. So there's a project out there that's called OpenDataHub that is trying to kind of do an opinionated way to create an AI platform, using the most common AI tools that are out there in terms of the notebooks that the data scientists might be working with, the libraries that they need, the storage that you need, and all based on kind of cloud native projects that you can also deploy on your Kubernetes environment. So OpenDataHub is basically a Kubernetes operator that allows you to create this platform. That's basically it, right? So it's in terms of development, you can use this tool, and this is also there to serve the models and to serve them on Kubernetes, potentially even as serverless workloads, because yes, AI uses a lot of GPUs, right? So if we can scale up and down based on which model we need and the demand, that's also a nice feature to have, right? So let me show you a quick demo of what this might look like. So yes, disclaimer, I work at Red Hat, and OpenDataHub is something that Red Hat, as an open source company, it's really important for us to make sure that open source projects are key, and we've seen a lot of innovation here. And so this is something that Red Hat is contributing to, and also is the basis of OpenShift AI, which is kind of an implementation of this OpenDataHub. So you'll see the logo OpenShift AI, but just imagine that this logo isn't there. It's just OpenDataHub, right? So you have this kind of portal. So this is what the data scientists can use, what the ML engineers can use to provide a platform for creating AI. So you can see here we have some data science projects. We have a way to train, serve, monitor, and manage the AI models, and then some learning resources, whatever more. So in this case, I created already a little project to create some images, because I don't know if you saw here before the session, there were all these pictures on the wall, and there were a lot of dogs. So that's what we're going to try to generate here. So you can see here, meet Red Hat Teddy, and that's exactly what we're going to try to generate here. So in my platform here, I have an image generation workbench that I already created, which has some data pipelines tied in. So the ML engineers, they would set this up for the data scientists, and then also deploying the model is easy from here as well. So we have a Jupyter notebook here. So this is served in this workbench. And so I created a few notebooks, and by me, I mean mostly my colleagues, because again, I'm not a data scientist. But here's kind of how that goes, right? So you experiment with some model. So that's how you start, right? So just like I was showing at the start. So we need to do some experimentation of a model that we found on Hugging Face. So we found this diffusers library. So we use this model that we found, and we want to train it. So we load this pre-trained model based on Stable Diffusion. If you're familiar with that, it generates images, and then we ask it, create a photo of a dog. I'll make this a little bit bigger. And so then you can also provide a negative prompt, which basically means like, don't make it like this. So we said, don't make it an ugly dog. Sorry, ugly dogs. We don't want to make it deformed with like 5 legs or something, or bad anatomy. And so we asked it to create a photo of a dog, and this is what it generates, which is, admittedly a very cute dog, but it's not Red Hat Teddy, right? So remember, this is our dog. This is our team's mascot. He likes to wear his little red hat, and this is what I wanted to generate. So I go back to the model and I say, try to generate a picture of Red Hat Teddy. So we ask it a photo of Red Hat Teddy dog. And of course, this is a non-trained model, so it generates, again, a cute dog, but it's not Red Hat Teddy, right? We want Red Hat Teddy. So we have another notebook to actually do the fine-tuning. So, this is a little more advanced, right? Because we are going more into the data science and fine-tuning models. So we couldn't use InstructLab for this thing, but we could use some, of course, Python in this case, to train the model. So we took a bunch of pictures of our teddy dog from different angles, and then basically that's what we're training the model with. So you can see here, I'm not going to run this live because this takes a few minutes. But just imagine, this is all happening. So we get our training data, we set up the job, start training, and then eventually we have a trained model. And then we have to save it somewhere, right? So we can save this as part of this environment in an S3 type bucket. So there's like Minio or whatever that we can save it in, or AWS S3, whatever is available to you. And then from there, we want to serve it. So you can actually serve it from the same platform. So long story short, now we have a model that's being served here on this open source platform using only open source projects. You can find all the projects that we're using on GitHub, and now we have an inference endpoint where we're serving this model, and now we can see if it works. So I'm going to run through this final notebook, and then we'll see what happens. So I hit kind of restart kernel, so it goes step by step through the different instructions of this notebook. That's how Jupyter Notebooks works. And so you can see it already went through step 1 and step 2. And then here we can see a star, which basically means it's still running through this part of the model, or of the notebook. So hopefully we'll see this in just a second. So we see 3 and 4. And now we're actually opening the image, and we can see that, hey, that's actually our dog, right? Or at least looks very close to our Mr. Teddy. And we also asked it wearing his fedora in the snowy mountains, and we sure enough have it in the mountains. So this is great. We were able to use a model, train it, serve it, and then operationalize it with a pipeline and everything. Using open source projects. So I think that's kind of where we need to go as an industry, is using these kind of open source projects, and just to show that it is possible to go through it all. So now we have our inference server, we have our Red Hat Teddy. We want to now start using it, right? So that's where, of course, the application developers come in. Before we go to the application developers, just to kind of point out a few of the projects that we were using here, like Kubeflow pipelines, Kserve model mesh. So those are some of these open source projects that are leveraged to serve the model for the pipelines of the model. So those are some interesting projects. And then the third project here, you might have heard of it already. It's not super new, although it's relatively new, is Backstage. So for the application developers, they need a little bit of help to get started with like how do we actually integrate this into our application, right? So we see a lot of movement towards like developer portals for application developers to have like a portal where they can access all the projects that are available, but they can also get started with projects that are opinionated, that already have kind of the needed bits and pieces built in terms of CI/CD or where to find their applications and so on. And so on and so forth. So we added a new kind of template in this Backstage to use our AI model. So I'll show you that real quick as well. So we here have our Backstage and created a new template for our Red Hat Teddy application. So you can see here that we have a Where's Teddy Python application. And so for a developer, what they would do is, hey, I want to start using this this model. The ML engineer and the platform engineer would create a template, and then you can create a new Git repository that would already have, a lot of the needed data for the application. So, we can supply here an organization, and we can create a new Git repository. Then we have, the cluster ID already pre-filled to put this in a Kubernetes environment, and then, Kevin at DevOps as kind of a project. And you can see here they've already pre-filled the URL for where the inferencing server is as well, and then we can set the owner to, me, And then based on that, it has pretty much enough information to create a project that already has kind of an opinionated starting point for me as a developer to get started with. And so I already created this. I'm just going to skip forward here and go to our Gen AI. I think it's this one. So here, basically from this platform, the developer already has access to, the source code that's in GitHub in this case. There's a pipeline that was created for my application. So everything is kind of set up, and then I can start developing. Potentially even, like you can go and access, an IDE. And so based on that, the application is now up and running here in the cloud, and so we can try it out as an actual application that integrates the AI model with CI/CD and whatever more. And so we can ask Teddy again, right? So, or we can ask the model again, where's Teddy? So in this case, I guess we'll say in Antwerp. I don't know if that's going to work. By the river Schelde. Schelde. And so we'll see what happens. So go, and it'll of course take a little bit because our model is running in the cloud, and we have internet here that's not super fast. But we'll see in a minute, hopefully, that it'll generate another picture of Teddy. And again, trained because it knows that who Teddy is, and it knows that Teddy likes to wear his little hat. And so we'll hopefully see that in just a minute. Here we go. Here's Teddy. Let's imagine that that's the Schelde. Not sure what is going on with his poor little paw there. But yeah, so just to kind of show you how you can leverage, AI and go all the way from kind of the initiation, experimenting with a model, to training it, to serving it, and then for the application developers to also kind of access this data in a manageable way, right? Because like we're not all data scientists and we're not all experts in AI to get started. So that's cool. But we're here at DevOps. We like Java. I'm also a Java champion, so I really like Java as well. And maybe you already heard of LangChain for J. Maybe you've heard of Quarkus. I'm assuming yes, right? Because we've had a lot of talks about it. But I want to kind of take a step back to application developers who want to integrate AI models, but maybe don't have access to a cloud environment like this OpenDataHub that's already serving a model, that maybe don't have the permission from their organization to use AI from some random model, or maybe they can, but they don't know where to get it. They don't want to spend money to get a subscription for some AI provider. So there's a few ways that you can work with AI on your local machine. So you may have heard of Ollama, for example, which is a cool way to serve models on your local machine. Actually, the InstructLab that I was showing earlier, I was actually serving a model on my local machine on a port that is exposed, and I could use that too. But I want to show you another project, which is Podman AI Lab, which also allows you to kind of work with AI models in a fairly intuitive way on your local machine. That's also a purely open source project that's out there. So let's try that. So I'm gonna make sure that I stopped my server here from InstructLab. I don't want to run too many things at the same time. There we go. I'll go ahead and start this Podman desktop. So basically, Podman desktop is like Docker desktop. So allows you to work with containers. So if you're already working with containers, you may already be using this, so you can see your containers and whatever more. But so what I found interesting is that there's an extension AI Lab in there, and so this AI Lab is interesting. So you can find a catalog here that has already some open source models, and again, open source kind of in quotes, right? Some models are more open than others, whether you can contribute back to them or not is is sometimes debatable. But you can see here InstructLab Granite. That's one of the models that comes from IBM with their Granite models. That's the one where you can actually contribute back to the project as well. So we can use that one. InstructLab Merlinite is another one. So from Podman Desktop, you basically have those models available. You can also just import your model. You can download one from Hugging Face or one that you've built yourself, and then play around with it. So I'm gonna serve maybe this one since I see it's green. That I'm sure it's already been downloaded. And then I'm going to expose it on port 35,000 just because I know that my application is looking for something on port 35,000. So I'll create this service, and that again starts up a model running purely on my local machine using Llama CCP. And so before we go to our Java application, just to kind of show this AI lab a little bit more, there's this recipes catalog too, where you can create for example, a chatbot or also a summarizer, code generator, or whatever more. So I thought that was kind of interesting because it shows you all the source code that's behind how to create this, and then you can clone these repositories as well. Anyway, so now this is running on my local machine, 35,000, and so let's go to my Quarkus application right here. And so this is based on Quarkus LangChain for J. If you have not heard of it, I'm assuming you have, but so basically a LangChain for J is a convenience layer, let's say a library to work with AI models, right? So it makes it very intuitive, and then thanks to Quarkus, and it has a really cool developer experience, you can make it even easier. So in this case, I added the Quarkus LangChain for J dependency to my application, and you can see here it uses LangChain for J OpenAI. And so you're like, well, but aren't you using Podman AI Lab to serve this model? Yes, I am. It actually exposes the OpenAI spec. So that's probably at least one thing that's open source about OpenAI is the specification they did open source that one, so you can actually use the same specification for serving models as well, and so that's what's actually happening here. So I can use the OpenAI extension from LangChain for J in Quarkus, even though I'm not using OpenAI. So you can see then in my application properties here, I'm pointing my OpenAI base URL to localhost 35,000, and then I set my timeout a little bit longer because, yes, I am running this on my local machine, and I don't have many resources, and this model is a little bit bigger than the one that I showed before with InstructLab. So we see here that I'm also setting log request and response to true, so we can see what's going to happen. So, and then finally, I have the assistant here. So the assistant is basically where you tie in the AI service, right? So you annotate with register AI service. You set, some context. So in this case, I set it to, you are a Java developer who likes to over-engineer things, just to like make it a little bit more interesting, let's not give just a very simple example, try to over-engineer things. And then, in this case, I also added a fallback. So that's something that is really easy to add if you use Quarkus and LangChain for J as well. In terms of like, you call a model, but what happens if the model is not available, right? We want to make sure our code is robust, not only in terms of REST calls, but also in terms of AI models, which incidentally are also REST calls. But in this case, you can see there's a fallback that answers with failed to get a response from the AI model, so it gracefully handles errors, and then a retry as well, so it retries 3 times, and then has a delay of 100 milliseconds. So just kind of give that as background information. And then we're going to call this model from a simple REST endpoint here that's going to prompt generate a class that returns the square root of a given number. I don't know. If you have a better idea for a message, let me know. I'll just run this. So in the Quarkus dev mode. So basically, I'm just going to start this application running on my local machine, and then it should expose port 8080 in just a second. So we can see that it should be up and running in just a second. No, it already is running, sorry. So now if I go to my browser, you can see that I opened it in Firefox, and we can see that the request already went off, right? So to localhost 35,000, and then it says model GPT-4o mini, but that's actually not true. It's it's the model that we are running, but like the LangChain for J OpenAI extension by default sets GPT-4. The thing is, I'm only serving one model, so I don't need to specify the name. So this kind of just gets ignored. But you can see the system message, you are a Java developer who likes to over-engineer things, and then the message is generate a class that returns the square root. Our temperature is set to 1 in this case, so a little bit, it can be a little bit creative, but not too. And then let's see what happens when it responds, which should be, hopefully pretty soon, but it takes, sometimes a little bit of time here on my resource-starved laptop. Here we go. So there's the answer. Let's look at it in the browser, and here we go. So it did create, fortunately this time, a Java class, which is what we asked. Well, we didn't ask for a Java class, but we did say in the context that, hey, you're a Java developer who likes to over-engineer things, so presumably they would create Java code, right? The other day, I was demoing this in our hands-on lab, and it returned with Ruby code, which was fascinating. So Java developers who like to over-engineer things sometimes like to write Ruby. I don't know. Anyway, in this case, it is Java, and you can see it generated a slightly over-engineered, I think, example of how to calculate the square root. So, but I guess the takeaway here is that, for Java developers, it wasn't that daunting of a task, right, to integrate AI into my application, and I was able to do this on my local machine using an open source model that I could potentially even contribute back to, right? Because this is one of those InstructLab models, and I could use InstructLab to go and train that model even further to make, maybe generate some even more over-engineered code. So that's if I can go back to the slides, there we go. So yeah, we saw Podman AI Lab. So to kind of wrap it up here, so the current AI landscape is growing fast, right? So what I showed in terms of the landscape is already quite overwhelming, and I think it's getting even bigger. But I think what we really need to make sure is that we can democratize AI and make sure that it's available for everyone, right? There's a time and a place for data scientists, for sure, but I think in terms of adding, common knowledge, it shouldn't be, the realm of data scientists. I think, use these projects like InstructLab are key to kind of opening up this AI world to, to everyone. In terms of training the model, and in terms of serving models as well, and making platforms available that should be open source, and we should push for that so that providers work together and also create open standards for everything. We've seen that at least with the OpenAI spec as well, right? So we can, I think, go further, but it is our responsibility as users to make sure that we push that and that we also contribute back, right? So. And then, of course, we want to embrace the same things that we've embraced for regular applications, right? We want to use platform engineering. Those kinds of concepts are really important to operationalize this kind of new world. And I hope I showed you some examples of how to do that. There are other projects out there, so this was just kind of a highlight of models that I'm personally involved with. But hopefully this was interesting to you. And then you also saw how traditional engineering can infuse and work with AI as well. And I think we're just at the beginning of what's possible in that world as well. So that's it for me. So thank you very much for joining the session. I know there was a lot of competition at this time slot, so I really appreciate you being here. The slides are available, I hope, using that QR code. And then, you have links to the different projects. And then please, provide some feedback about these projects. We would love to hear from your experience with them and your needs, because, that's also open source, right? We can work together on making this better. So Thank you, and have a nice rest of the day.